Good evening, everyone. Good evening, and welcome to the class. Right? So, today we are here on our channel in this session of maths to start another very important chapter, which is application of derivative. And why this session is important? Because in this class, I'll cover up all the conceptual side. Okay. Of course, I have problems also. I'll give you homeworks as well. So all that is there. Yeah. But three branches, basically three types of question comes from this chapter: rate of change, it is increasing decreasing function, and maxima minima. I'll discuss all the three concepts today itself. Okay, so please make sure that if you're here, stay till the end and make sure that you've learned and clear your doubts regarding these three topics. All right, now before I begin, for all of you who are in the class, good evening, and let's check if I'm clearly audible, visible, or not. Yes, so yes, I am clearly audible. Let's check if my visible. Okay, audio is clear. Yes, audio is clear. All right, guys, just a second. Great. Now, what I was saying, application of derivative, the part one. Now, in this class, we'll talk about your theory, your questions. So, I understand your time is important. Let's not waste any time and start the session right away. And if you are watching me for the first time, if you're joining this session for the first time, do not forget to share this particular class, this channel, and this chapter video, this session with all of your friends, because I'm telling you, if we are coming here, whether it is live, recorded, if we are coming on our channel Diksha Karnataka, it's for only one purpose: to add value in your preparation, right? And for that we have done and we have taken numerous efforts to make your preparation, make your learning easy, fun, as well as rewarding. So all have been done since past few years for KCET and of course for boards as well. All right, guys. So clear. Let's start the class, and we'll do more talking as we, continue the session. Okay. So the first concept that we have today is on what? Rate of change of quantities, right? On the rate of change of quantities, and I hope all of you are better using the AIO platform, which is given to all of you, all-in-one learning platform, right? So it is completely having all the resources that you need, means all the YouTube lectures live recorded for grade 11 or for first PUC, second PUC student is available. Your class notes of the teacher notes are available. You have doubt solving access as well. You have uh, uh, test assignments, all is there. Okay, just click on the link given in description as free ACE KSAT course, okay, for 2027 batch, and you can access and log in from there. Again, after some time I'll show you how it works as well. Let's start the class first, and then later I'll give you a demo that how can you actually learn and access the platform. Okay, rate of change of quantities, this is very simple. This we can take different examples to understand, because specifically no, will not apply this to any functions. This is basically more applied, this is one of the most applied concept. So this chapter is what? The chapter is AOD. This is the most application based question that is gonna be coming from this topic only. So maxima minima is there, but whenever maxima minima or increasing decreasing functions are given, no, they'll be given, they'll be asking you find the increasing decreasing in that interval, or they'll ask you find the maxima of at that point. But that looks more mathematical than real life, correct na? But in this chapter, this particular concept, rate of change of quantity, it doesn't look so mechanized, doesn't look so function based, doesn't look so much of just math based. It looks more realistic, it looks more, the questions over here are basically real world problems. Okay, yeah, yes, got it, guys. So we can take for example concepts like, we can take over here concepts like volume change questions are there, area change questions are there, velocity, displacement, all these different type of change of quantities. That's why we have the word over here as quantities. And with the rate of change of quantities, different quantities, different physical quantity that you learn in physics of course, are going to be dealt with over here, right? Again, change of volume with time, change of volume with the radius itself, all of this will be there. We'll see different type of questions also. Let's start the session. Okay, so there's two type of change. If you remember, if you just talk about change, let's say before we go into a rate of change, let's talk about change. So when we talk about change, sir, okay, we have two types of change. Number one is average, and number two is instant. There's an instant change and there's an average change. So based upon question to question, scenario to scenario, yeah. Hi Mishra. So this is going to be so on the platform Diksha Karnataka beta, the learning will be only in English. So the mode of education, mode of learning on this platform is English. We will not be able to uh, uh, be teach or explain the concepts in Hindi over here. This is sole for the purpose of, this is an English channel by the way. Diksha Karnataka is a channel where we are teaching only in English. Mode of language will be, mode of teaching will be in the English only. Okay, let's continue then. All right, guys. So if you look at this change, as I mentioned, it's either average or instant. It's either average or instant. Examples, sir? Yes, we have examples. Average velocity or instant velocity. How do we discriminate between them? So average velocity is where if I went from place A to place B, went from place A to place B, I can know what is the distance over here. Let's say distance is how much? 60 kilometers. Okay, and it took me, let's say 1 hour. I'll say my average speed is what? 60 by 1. That becomes basically 60 kmph. That's my average speed. What about instant speed? So if you look at the odometer, means your speed where the gauge is there, or you have digital odometers these days. If you look at those, you'll find at any given instant you'll find a speed. You might have be driving at that instant at 85 kilometer per hour. You might be driving in a traffic 20 kilometer per hour. So this keeps changing. That is that instant rate of change. Okay. Again, when you're talking about rate of change, if you talk about rate of change, it means what? This is in our syllabus, in our terms of examination. This is always, or most of the cases, is with respect to time. Maximum number of times. Again, this is usually, we will be referring to rate of change with time. Hi Sania, how are you? So this will be with respect to basically change with respect to the time. So change, average change in displacement will be average velocity, and instant change in displacement will be instant velocity or instant speed. All right, guys. So again, if we have to look at this as well, little bit more, if I go in the understanding of this, let's say this is my dt curve. Dt curve is displacement time curve, and my curve looks like this. Okay. What is this? The function dt curve looks like this, and I want to, let's say, know from this point to this point what is the average change in velocity. What is the average velocity? I want to know. So if I want to find that, this is called as t2. This is t1. This point is let's say d1, or yeah, let me write this as y only, it'll be easier. This is y1 and this point is y2. So if I want to find out, let's say, this particular value, how do you find this? You end up finding m. M represents slope of this chord. Let's say if I write this as AB, slope of the chord AB will be given by delta y upon, in this case, delta x, change in the y coordinate and x coordinate. Over here, delta y is what, beta? Check here. This is y2 minus y1 upon x2 minus x1. This is going to be the slope of AB. We have learned this, right? But whenever we talk about instant, what we do, we try to talk about another point which is going to be here only. Let's say t2 dash. It means when t1 is very close to t2, very, very close, exactly the same point, means time gap is very small. Okay, then basically what happens, this either I can call delta t or delta x becomes almost 0. If they are very much close, what happens, this chord, if I keep moving from here, this point, like this, if I keep moving, if I move to this point, this chord will become a tangent. This will become a tangent. So basically when I take delta x to 0, this transform into dy by dx, and this is called as instant rate of change. Okay, and this represents what, guys? This dy by dx is a derivative that represents, what is it? um, Slope of tangent. Dy by dx is slope of the tangent. Clear? Clear? Okay, let's move on. Same thing written over here also. If you look at this, y equal to fx, then dy by dx is the rate of change of y with respect to x. Okay, and if you talk about delta y by delta x, it becomes basically change in x, f of x plus delta x minus f of x upon change in x. Basically change in y upon change in x. Okay, because x went from x to, this x value has gone from, if I take this as delta x value, this becomes what? X plus delta x. The x has gone from x to x plus delta x. So change in x is what? Delta x value. That's why you can see over here, this is delta x. And this is what? The function value at this point, which is f of x plus delta x. And this is nothing but function value at this point. Basically, what is this going to be? If I talk about this, this represents your delta y only. This is nothing but the numerator over here you see is basically this delta y upon delta x. See? And then you take delta x to be 0, it becomes dy by dx. Same thing I've taken over here. Alright, guys. And some formulas, because 5 formulas are important. We're going to use all these formulas. Area of circle, okay, spheres, volume, then spheres, surface area is also there, 4 pi r square, cubes, volume, equation of a triangle, okay, equilateral triangle. All of this is useful. Next, velocity and acceleration. So we just saw right now, if I have a displacement function, let's say I have written st as something, okay, let's say this is given as s is f of t, the function is s is f of t. Then if I differentiate s with time, I'll be having what? Change of speed, or change of, sorry, displacement with time. This is called as velocity. We write this as first derivative of the function f dash of t. It's available, right? MC Malik, it's available in our, those assignments are available in AIO page. Okay, tests, questions are available in AIO page. Topic wise, chapter wise is available. Malik, yeah. Great. Okay. So velocity is ds by dt. What is acceleration? Again, if you change the velocity, so dv by dt will be acceleration. So if you want to write in this case, dv by dt becomes what? Your acceleration. You can either write this or you can write the second derivative of this also. That becomes simply d square s upon dt square. D square s upon dt square. Yeah. So extra questions for practice are provided in the form of tests. Please go and check in the AIO page, all-in-one learning page. Okay. Yes. All right. If velocity is 0, what it means? You're moving in the positive directions. This is all basic concepts of physics only. Velocity is less than 0 means we are still moving, but in the opposite direction. Let's say if I take from here to here as positive, then v positive means this way, and v negative means this way. Usually, negative velocity questions I have not seen recently being asked in boards, but they do ask negative rate of change questions in terms of yeah, there is actually one question that I've seen. I'll show you that as well. When a person is moving away from that, let's say from a pole or from a lamp post, that type of question is there. Negative or positive velocity questions. Yeah, but usually you'll have rate of change of questions in terms of whenever this problem is there, no? Rectangle, when this is x and this is y, x is reducing, it becomes negative. So negative type of change is also there. That's why this is mentioned over here. Okay. Yes. So let's look at this question and solve it. A basic question. So basically, since this is one of the most application based concept in this particular unit, okay, and for that reason we'll solve questions to understand this. Okay, I think I have 12-13 questions. Let's solve all of these, and you all can try also, give me answers in the comment section. So t cube minus 6t square plus 9t plus 5 is the displacement function given to us, and we want to find velocity. We want to find the velocity as well as the acceleration, okay, at time equals to 2. Okay, 2 units, whatever it is. So to find the velocity, I need what? ds by dt. Differentiate this. You will have 3t square minus 12t plus 9. We want to find this when v value is, when time value is 2. So v at 2 will be how much? 4 into 3, that's 12, minus 24 and plus 9. Correct? Let's cross check again. 12 and 24, correct. This will become minus 12. Minus 12 is over here, and plus 9, that becomes minus 3, right? Again, we don't have any units, so we'll just write here units per second. There's no unit given over here, right? There's no unit given. We can write meter per second also, but I hope this is clear. Now, if you talk about acceleration, it will be what? D square s by dt square. Differentiate once again. So we'll have 60 minus 12. That becomes what? Put the value 2 over here. Get 12 minus 12. That's coming as 0. So acceleration is going to be 0. So at the point time as 2 units or 2 seconds, my acceleration value is 0. Okay. Correct, Sanya. Yes. Next question. Next problem. Circular oil spill. This is an oil spill, okay? And the way the oil has spilled, it's going in circular forms. It's like moving like this. The oil spill is moving like this. Okay. Now they're asking us to find out rate of area, means how fast the area is changing when the radius is increasing at this rate. It means they've given rate of change of radius. dr by dt is given as 2 centimeters per minute. And they're asking us rate of change of area when this radius has become what? Equal to 3 centimeters. Let's say that. Again, this is the rough diagram, guys. So don't be, this is not an accurate diagram, just a rough sketch of what is happening. So let's write circular area first. We'll have pi r square, differentiate area. They're asking us this only. We get 2 pi r dr by dt. So 2 times of pi. R value is given as 3. And this is also given as 2. Right? That is 2. So we have 3 to the 6 to the 12. 12 pi. Change of area. So centimeter square per minute. Centimeter square per minute. Time they've given in terms of minutes only. Did you all get the same answer? Okay. Yes. All right. Now, some questions I have brought, as I mentioned, some board style as well as CT style questions. Let us solve this. Let us solve this. Guys, try. Options are on the screen. Try to solve this. Yes. Sania, what is the answer, bacha, for this question? The rate of change of area of a circle with respect to its radius. Again, what are they asking? Change of area with radius they're asking. So we'll not worry about that dt wala part. Differentiate. What is the area, guys? Pi r square. Differentiate this. You'll have simply if you continue over here, you'll get 2 pi r. R value is 6. That becomes 12 pi. Answer is option B. And yes, question like these are there in your boards. Okay. Question number 2. Answers, guys. Question number 2. Anyone? Shania, try this. Yeah. Okay, spherical ball, balloon is being inflated. So balloon is inflated means you'll have a spherical balloon means it is going higher in volume like this. Okay, so basically volume is increasing. So we have the volume being increased. We have the volume is increasing, and they're saying when you are filling in the air, what happens? Volume is increasing, and when you're doing so, the radius change is given to us. dr by dt is given as 3 centimeters per second. That is given to us. They're asking us find this rate of change of volume when you have radius as 5. Means let's say this was radius r equal to 5. At this instant, what is the volume change? Yes, anybody? Will you try this? Come on. So volume formula is what? 4 by 3 pi r cube. Differentiate the volume. You will have 4 by 3 pi 3r square dr by dt. Correct? Because here the change with time they're asking. The rate of change of volume means in terms of time only. Otherwise, they'll mention with radius. Okay? So this 3 and this 3 cancels. You have 4 pi r square, and this value is given as 3. So right here 3. Check. We have 12 times of 1 second, 12 times of pi, and r is given as what? 25. So r is given as 5, will become 25. So answer will be 25 times 10 is how much? 250 plus 50 again, it becomes 300. 300 pi. Change in volume means centimeter cube per second. Centimeter cube per second. Look carefully again. 25 times 10 is 250 times 2 also. If you consider, it will become 50. Add them. 300 is the answer, which is option number C. Option number C. Yes. Okay. Yeah. Any doubts so far? Any doubts so far? No. Let's go. The side of an equilateral triangle is increasing. The triangle and rate of change of side. Basically, this A is given. They'll ask a rate of change of area when A value is 10. We know very well area is given by an equilateral triangle as root 3 by 4 A square. So differentiate bacha. Differentiate this, you'll have root 3 by 4 as a constant. This becomes 2A dA by dt. We have all the values, so please put the values back. 2 here, A value is given as 10, and this is given as 2. This 2 cancels, we get 10 root 3. We get 10 root 3 centimeter square per second. This chapter will be in your midterms for sure. And I am covering all the conceptual part of this today. We will do the PYQs in the next class. Okay. So PYQ of CET will do in the next class, but today I have taken questions for the boards level so that your preparation is done in that way, so that your midterm side is at least prepared. Again, we'll help you more for your midterms. We are working on something very special for all of you. Very soon you'll have the reveal. But for now, just try to understand the basics of this chapter and be able to apply the concepts of this particular topic in problem solving. Okay. Next. S equals to TQ minus 6T square 90 plus 5 displacement in meters. Velocity of the particle is given as 3. We want to find the velocity. So how do you find velocity, sir? Differentiate it. You'll have 3T square minus, sorry, minus is there. Minus 12T. That's going to be 0 only. This part is 0. Now put this value as 3. So we'll have 3 times of 9 minus 36. That becomes 27. Minus 36, how much is that? Minus 9. I made a mistake. Yes, we have 3t square. Okay, yes, I have made a mistake. This should be plus 9 also, right? So it's coming as plus 9 as well. Am I right? 3t square, 12t plus 9. So 27 minus 26. Correct. Yeah. So answer becomes 0. Option is A. My bad. Calculation mistake. Okay. Question number 5. The radius of a circle is increasing uniformly at 0.2 centimeter per second. They're saying rate of change of radius is given. dr by dt is given as 0.2 centimeters per second. The rate of increase of circumference, they're asking us circumference change dc by dt. Okay, is what? Circumference is given by, guys, 2 pi r. 2 pi r. So if you differentiate this with t, you'll end up with what? 2 pi dr by dt. You have 2 pi and this value is given as 0.2. That becomes 0.4 pi. This 5 you see over here is not relevant to the rate of change of circumference. So 0.4 pi. 0.4 pi is the option number B. 0.4 pi is the option number B. All right. Question number 6. The area of circular oil spill is increasing at 16 pi centimeter square. We have done a similar in the solved example as well. So this is given as dA by dt is given as 16 pi centimeter square per second. What do we want to do? We want to find rate at which the radius is increasing. Okay, we are going to find the value for dr by dt. So let's again go ahead with this. A is given as pi r square. Differentiate, bacha. We'll have dA by dt as 2 pi r dr by dt. So you can see most of the questions have same principle. Two categories are there. One, when you differentiate with time, then you'll have the chain rule for dr by dt. Once the easier ones where you don't have to differentiate with time, only with radius or something else will be given like that. Those are the two categories of questions. Okay. So this value is given as 16 pi. 2 pi is as it is. And r value is given as what? 4. This is the unknown. This is the unknown. So it's going to be what? 8 pi. That becomes 2. So dr by dt is coming as 2 centimeter per second. This is coming as 2 centimeter per second. Yes. Yeah. X equals to t square plus 1, y equal to t power 4 plus 2. Then dy by dx at t equals to 1 is what? This is the question of rate of change application in parametric form, right? How do you find dy by dx? You find like this. Dy by dt upon dx by dt. Differentiate this. You'll have 4t cube plus 0 basically. And over here we have 2t. Correct? Differentiate y, you'll have 4t cube. Then you'll have 2t. Getting over here, check this out. 2t square. Put the value as 1. So answer becomes 2 times of 1 square. That's nothing but 2. That's nothing but 2. Yes. Guys, AIO page link has been shared over here. As Malik was asking, you're welcome, Santoshi. As Malik was asking that, sir, do we have more questions in that? Yes, we have. If you guys want, I can show you how do we access that. Okay. So let me just save this file first. The class notes, very important, it will be shared over there. So if you look at this, 1 second. Acha, are all of you using already? Hi Rama, hi Ram, how are you? Good evening, sir. Sir, you are launching KCET test series. I have a doubt. Is the PUC plus mock test enough for KCET? PUC plus mock test. PUC plus PYQ plus mock test. Please do that. Ram, PUC plus PYQ plus mock test. Okay. And a serious practice will be enough. Correct. Okay. Let me show you this first. Here we go. So I hope all of you are using this, right? Are you all using this particular platform given to all of you? Our AIO platform, free ACE KCET course. If you click on that, this page opens and you have to create your own login, right? I have done that for myself. Don't worry for the buy now. This is completely free. And mock test price is beta 1499. Okay. For students who are not part of the Pariksha Vida batch, who have taken the full year course, you'll have a 500 rupees off over there in the fee. Okay. So if you click on the continue, you check over here. This is your subjects by segregation, physics, biology, mathematics. And again, if you want to just check maths, you'll find all the lectures, assignments are also there. All is there. Okay, you can check in this also. One second. Let me just show you the tests parts as well. Yeah, my tests. So let's say I missed this test. Okay, so I want to go and test myself matrices. Okay, so I am not a bio student. I can check myself for matrices, let's say. So I can check the syllabus. I can attempt now as well. All right, guys. So you have more question practice in terms of this as well. Acha, don't think that, sir, these are tests. How will this be practice? Bacha, this is test is something which is exam. Okay, this is all part of preparation only. This is not a test like like CET. Any test before CET or any board exam, any pre-board is going to be what? Like a preparation only. So just please treat this as preparation only. You see the syllabus, prepare as per the topic and start attempting, start learning. Don't think of this as a test. This is all part of preparation journey only. Okay. So treat them also as assignments, questions. They're provided over here as well. See, so in my profile, I have not attempted any test. So it's showing missed 6. Getting it? You'll find these tests are published. So please go and check it out. Okay. And don't worry, we'll keep publishing more also. Yeah. But things have been there. That's for test wise. Now, if you want to, let's say, I want to attempt a quiz. Sir. But I want to attempt only for physics, sir. I don't want for maths today. I'm done with maths. Let's say I want to attempt for this. Then I'll go and check these classes. All the classes are there. I can play the lectures. Okay. I can look at the slides also. All the slides will be also available over here. And as well as the quiz also will be available over here. You can see the quiz is also available. So please better start using this platform. This is for your benefit, right? Yes. Anybody has doubt regarding the AIO platform, all-in-one free learning platform by Vedantu? Let me know. Yes. Chalo, let's move on. This question must be clear. So last 2 questions, then we'll start the increasing decreasing function. Okay. Yes. The displacement of a particle s equals to 2tq minus this is given particle at rest. Okay. We're looking to find the time when the particle is at rest. So rest means what? Rest means velocity is 0. So we'll find the velocity function and equate it to 0. Velocity is what? ds by dt. We get 60 square minus 30t plus 36. Okay. And we want to find the time when velocity is 0. We'll put this equal to 0. Take 6 common. You'll have t square minus 5t plus 6 equal to 0. Then if you factorize this, you'll have what? T minus 3 and t minus 2 equal to 0. Okay. Correct? No? Check this over here. T square plus 6 minus 3t minus 2t. Correct. Right? Yeah. So either t equal to 2 second or 3 second is my answer. My option must be what? Option C. Anyone is getting a different answer, please let me know. Ram, are you getting a different answer? Ram, are you getting a different answer than this? Clear? Okay. The volume of a cube is increasing at a rate of 9 centimeter cube per second. Okay, so we have dv by dt is given 9 centimeter cube per second. The rate of increase of its surface area, they're asking us ds by dt is what? Try this one. First, you guys try this. All of you in the class. Try this once. What is the problem over here? If you look at the formula for this S, this is sir 4 pi r square. Differentiate this. 4 into pi into 2r dr by dt. I'll get 8 pi r dr by dt. 8 pi r dr by dt. This is what I'm getting. Am I right? Correct? So my problem is this missing value, because r I have as 10, but dr by dt I don't have. But they have given us the volume, and volume formula is what? 4 by 3 pi r cube. So start from here itself. dv by dt, you'll have this value as 4 by 3 pi r, 1 second, 3r square dr by dt. So this becomes what? 3 and 3 cancels. This is given as 9. So right here 9. 9 by 4 pi. And what is r? 10. So 100. That's the value for dr by dt. Correct? 4 pi and r square means 100. I will put the same value over here. We'll have 8 pi r. Okay. And this value is how much? Please check. 9 upon 4 pi into 100. So pi and pi cancels. Pi and pi cancels. This r is nothing but 10, right? So this also cancels, by the way. We have 2 times of r, which is 10 into 9 by 100. This also cancels. We have 18 by 10. So 1.8. 1.8 is option A. Anyone has doubt in this question? Anyone has doubt in this question? Please have a look first. Anyone has doubt? Okay, no doubts. Ladder 10-meter long rests against the vertical wall. If the foot slides away at, yeah, this is the question I was talking about. The movement wala question, negative, positive. So this is a ladder resting against the wall. This is the ladder, right? Let's say like this. 1 second, guys. This is the ladder. The foot slides away, means this is increasing, right? Check here. So this, if I take this as x and this as y, I have dx by dt given, guys, as 1 meters per second. 1 meters per second. How fast is the top sliding down? Means, of course, this will be reducing. This will be coming down. They're asking us dy by dt equals to what? Given that ladder length is 10 and foot is away now 6 units. Ladder length is 10 and foot is away by now 6 units. So if this is a right angle triangle, we know this value must be 8, because this is a Pythagoras triplet. 6, 8 and 10 is a Pythagorean triplet. 6 square is 36, 8 square is 64. Add them, it becomes 100. So that is basically square of 10. Square of 10. Okay. So if that is the case, I have all the values, first of all, that I'm going to use. One more thing. Since it is a right angle triangle, this is x, this is y, and this value is 10. We know that x square plus y square will be always equal to 10 square. Now differentiate this condition. You will have 2x dx by dt plus 2y dy by dt will be equal to what? 0. Will be equal to 0. I want to find this value. So I'll take everything on the other side. First I'll take this. So I'll get dy by dt equals to minus 2x dx by dt. This will go, so it will become negative, and divide by 2y. divided by 2y. 2 and 2 is cancelled. I'm getting what? Minus x by y dx by dt, for which we have the values known. X was 6, y was 8, and this value was given as 1. That becomes minus 3 by 4 meter per second. Mass by 4 meter per second. Okay. As you can see, as I told you, since it is reducing, it is going to be negative. Okay. They've already mentioned that over here sliding down. So of course, we don't have to check the sign. Just a 3 by 4 is sufficient. If they're asking what is the change, if the word change is mentioned without giving a direction, then you have to write negative sign. But they mentioned direction also as down, means they've already mentioned the negative part. So don't write the negative value again. Is this clear, guys? If in the question they have already mentioned down, it means they have mentioned the direction sense, so it will not be negative anymore. But if it was like, what is the change in, basically movement of y across, down, basically y, then you'll write the negative value, which is minus 3 by 4. Since it is reducing, that's why I've shown you this rate of change is negative. So I hope this is clear. This is clear. Okay. So that was application based questions of different category. Volume change, area change is there, surface area change, or velocity problems, ladder problems, all I have discussed. Any doubt in the first part of this chapter? You're welcome to ask. Yes? No? Any doubt, guys? No doubts. Next is increasing decreasing function. Now over here, this part, it can be one of the simplest topic because the concept is very simple. Derivative is positive, sir, and here derivative is negative, sir. And in maximum number of questions, derivative will not be, like differentiation will not be that difficult. But there will be some question which will be based upon quotient rule. Those might be a little challenging. Apart from that, rest all questions are very easier over here in the increasing decreasing function. So if I have to summarize it to all a student who has learned this chapter, derivative positive increasing, derivative negative decreasing. If you put just positive without equal to, it is strictly increasing. Put equal to, it becomes just increasing. This becomes just decreasing. Okay. Now before I go on and do all of this, let me just show you the trends also for each of the graphs. So 1 second. If I talk about increasing function, nature looks like this. First of all, condition is true. F dash of x must be 0, more than 0, and the graph curves looks like this. It is increasing, constant someplace, and then again increasing. This is the example of increasing or non-decreasing function. It became constant from the point, let's say, A to B. From the point A to B, the graph is constant, means having the same value, but it is not decreasing. It increased, remained same, then again increased. This is called as either increasing function or non-decreasing function. But we have other case, which is strictly increasing. Strictly increasing. In this, what happens? The graph will be having a nature something like this. The function will be like this, in a straight line. I can have a curvature like this also. Okay, I can have different nature of the functions. Okay, this is exponential, this is linear, logarithmic. So all will be strictly increasing functions. That's the nature. And how do you write this? Simple, sir. F dash of x is only positive, not even 0. Only positive, not even 0. Decreasing function. What happens over here? Again, we have two cases. When derivative is less than or equal to 0, the graph looks like this. Comes down, stops, again comes down. The function till the point A is coming down, so decreasing. From A to B, it is constant and again dips back, so decreasing. So this is a decreasing function or non-increasing function. It has a branch where it is constant, but it is not increasing. Decreased, constant, again decreased. It is not increasing. That's why it's called as sometimes non-increasing nature. Non-increasing nature. Other one is what? Strictly decreasing. Strictly decreasing, what happens over here? F dash of x is just less than 0, and for which graph will look like this, graph will look like this. All these categories are there. Linear, exponential. Any doubt, guys? Any doubt over here? Okay. So if I talk about increasing function, if x2 is more than x1, then f of x2 will also be more than x1. Here there is no equal to sign. The difference in both will be what? Have the missing of equal to sign in the inequality. So this is what? Increasing, only this is there. And strictly increasing, we have without that. We have without that. Same case in the this also. Yeah, sorry, I made a mistake. This is correct. Even if x2 is more than x1, example, sir, let's look at this. This is my x1 and this is my x2. X2 is more than x1 or not? Yes, sir. But f of x2 is what, beta? Is equal. They're equal. So equality can hold. So this is why it's called as non-decreasing function. It is constant for some time but not decreasing. Okay. That's why we have equality over here, but not in the case of strictly increasing. For that, there will be no constant side. Keep going high itself. All right. If this is just ulta, look at this, just opposite. We have decreasing, constant, back to decreasing. This value is x1, this value is x2. So even though x2 value is more than x1, you can find this trend over here. If I talk about this point and this point, you can see you go towards right, the y value is decreasing. The y value is decreasing. Okay, clear, guys? I've done all of this already. Okay. Working rule, not a big deal. Find the derivative. Set. This is for finding critical point. Okay, means basically whatever function is given, you find a derivative equal to 0, and you'll get at what point the derivative is 0. That's called as critical point. Sometimes we call it as stationary points. And in the case of maxima minima, we call this as what? Point of extrema or extremum. In the case of maxima minima, this value becomes what? Point of extrema. Point of extrema. It can be either minima, maxima, but only in that case. Okay, so you're gonna mark those critical point on the number line. Let's say whatever you got, you mark on the number line like this, and then you'll look at the trend using inequalities wavy curve method, and you will find the plus, minus, plus conditions. Plus represents what? Derivative is positive. So if they're asking for increasing part, you'll take those intervals. Decreasing part, you'll take the negative intervals. Okay, clear? Yeah, we'll see all of this with the question solving. Let's look at this question. Okay, fx is given. Find increasing and decreasing intervals. Means in what intervals the function is increasing or decreasing? Is that what they're asking us? Start from here. First step is to do what? Finding derivative. So we'll have 3x square minus 12x and plus 9. Next is what? Put equal to 0. Take 3 common. X square minus 4x plus 3. Can you find this factorization? Of course. The 3 is gone now because we can move this 3 on the 0 side. It will become x minus 1 and x minus 3 equal to 0. So we have over here we have what? 3, and this is x square. So we get x value as 1 and 3. X value as 1 and 3. Correct? Once we have this value, what is the next step? This is the critical point. Third step is to plot the number line. This is minus infinity. This is plus infinity. 1 and 3. Now next step is to look for, basically plot the inequality and find the, use the wavy curve method. So look for the coefficient of x, positive and positive. So based upon this coefficient, here also plus, here also plus, it'll become net sign is positive, and power of each is what? 1 1. So we'll go sign change, plus minus plus. Positive represents your increasing part, so let's write this. Increasing, which interval? When the x belongs to interval minus infinity to 1, I want increasing, so I can keep this closed. If I wanted strictly increasing, I'll have to keep it open. Union 3 to infinity. If I talk about decreasing, same way, x will be in the interval 1 to 3 closed. Again, I'm mentioning, if you had in the question strictly increasing or strictly decreasing, then there will be no closed brackets. There will be no closed brackets. Clear? Now we have some questions to solve. Any doubts so far, guys? Any doubts so far? Yes, motivate, we have done it. Okay, if you look in our channel, weightage, KCET weightage for maths, you'll find that video. Motivate, please check in our channel itself. Okay, what is it? I've done recently weightage for maths, KCET weightage for maths. You'll find the year-on-year trend from which chapter, how many questions have come. I've done that very recently. I've done that. Okay, please check it out. Yeah. Function fx equal to x cube minus 12x plus 2 is strictly decreasing on. Again, step is same. Differentiate, sir. We'll have 3x square minus 12 put equal to 0. Take 3 common, we get x square minus 4. So my critical point is what? X equals to 2 or minus 2. From here we get 2 or minus 2. Next step is to plot on the number line. Minus 2 here, 2 here, infinity, negative and positive. Plus minus, plus is the interval sign. Because of x nature here, you can see is positive. If you factorize it, you'll have what? X minus 2 and x plus 2. You have plus and plus in both the cases. So I start with plus sign, and each of the factors is coming only once. That's why I can do sign change alternatively. Okay. I want strictly decreasing, means I want negative part and I want open, because strictly decreasing means I cannot have the closed intervals. So open, and I have to take what? The minus side. So my answer is what? This only. My answer is option B. Yes. You'll find for chemistry also. Please check subject name, you can write over there. Okay. Next, question number 2. Function fx is given. Again, we are looking for it this time strictly increasing. Find derivative. We'll have 6x square 18x plus 12. Take 6 common, x square plus 3x plus 4 equal to 0. If you put, you can take, this will go on this side, it will become 0. So x plus 1 and x plus, what is it? 6x square, 18x and plus 12. So 6, if you take common, 3 and 2. Okay, this would be 2. My bad. This would be 2, right? Positive 2 will become x plus 2. Correct? Yeah. So x values are what? You can see minus 1 and minus 2. Number line will look like this. Minus 2 here, minus 1 here, negative infinity and positive infinity. Powers are again 1, 1. So plus, minus, and plus. I'm looking for increasing in this time. So we have this interval and this interval open bracket. Option is C. Guys, if you have doubt in any of the questions, please, you're welcome to ask. Any questions you have doubt, previous also, or this one, you can ask. This is a very good question. This has a similar form of this question has come for CET, by the way. Yeah, a similar form of this question has come for CET also. Not the same one, but similar has come. I think it was x square there. I'm looking to differentiate and then get the intervals for strictly increasing case. First step is to find the intervals. So differentiate. First step is to find the differentiation to find the critical point. So we have to use what here? We have to use product rule. X will be 1 e power x as it is plus x as it is. E power x derivative is e power x. Take here e power x common. 1 plus x. Put equal to 0, you get x value as simply minus 1. So you have minus 1 here, negative infinity, positive infinity. Why minus 1, sir? Because this over here is a non-zero value. How come, sir? E power x graph looks like this. This is the graph of e power x. It is never 0. E power x is never 0. Okay, for any value you take, it will be never 0. So this bracket must be 0. That's why x equals to minus 1 is the only critical point. I want for strictly increasing. Check here, this is plus, this is minus, because x coefficient is what over here? Positive. So I get here plus. That's my answer, minus 1 to infinity. I want strictly, so it'll be open bracket. What if, I have a doubt from all of you. What if this question was like this, e power minus x and 1 plus x? Then on the number line, again you'll have minus 1 over here. Will you put plus or minus sign over here? Anybody can tell in the class? This is important, guys. If the differentiation was e power minus x times of 1 plus x, and I were to plot this on number line, the critical point is still minus 1 only. But will this side over here will be plus or minus? Because here e power minus x is there. Tell me. Anyone? This is important. This will come in exam and you will make mistake. Please listen to me. I'm going to ask again. Here we have e power x. What if we have e power minus x, sir? From this point, we will not get any critical point because this is never 0. This is never 0. But this will be 0 when x is minus 1. So will I put here minus sign or plus sign? That's what I'm asking. Shall I put here minus or plus? Correct. I'll put plus only. Superb. Can I know your good name, bacha? I'll put plus only. Can I know your good name? Your ID is little different. What is your good name? But your answer is superbly accurate. Okay? Means you know your maths properly. The point is, whenever we are dealing with inequalities, right, we'll look for the sign of the factors contributing to the critical point. This critical point, I'll repeat myself. Whenever we're looking for inequalities, okay, on the number line, we look for the factors which contributes or which gives the critical point. Minus 1 is the critical point from where? From here. E power x or e power minus x does not give any critical point. From here, we don't have any critical point. So when we're looking for the sign, we'll look for the factors where it is giving a critical point. So we'll have to ignore this for the sign. So here we'll have what? Plus, simply plus only. So plus and minus, it remains same. So very good, guys. Superb. Good job. Let me erase this now. Let me erase this. 1 second. Just a second. Just came like this. Yeah. Okay. So question number 3 is done. Question number 4 now. If I have fx equals to cos of x in the interval 0 to pi. What nature is there? So usually in AOD we differentiate f dash of x, will find, we'll get minus sign, and we'll again check in 0 to pi the nature. That's not incorrect, but we don't need to draw the graph of cos x. 0 to pi means the graph is this. This is 0 and this point is pi. Look at the graph nature. Increasing, decreasing, what is there? What is there? Decreasing, sir. This is decreasing only. What about if I had an option, let's say decreasing or strictly decreasing? So I'll take which option? I'll take strictly decreasing. How come, sir? Look at the interval. It's open. Interval is open. So we'll not look at the point 0 or pi. That's why even though the question, let's say I had an option D as decreasing. Let's say option D was given here. You need to choose B or D. You will take the option B. Take the option B. We'll take the option B. Yes, Satvik, I'll repeat. Yes, I'll repeat. Yes, just 1 second. So what did I mention? Usually in this question, we differentiate, right, to find the nature derivative is positive or negative. But look at the graph of cos x. This is the graph of cos x, right? Graph of cos x is reducing only, no? At 0 it is 1, at pi it is minus 1. This is 1, this is minus 1. So graph of cos x is coming down. It is decreasing for sure. But if in this question there is no option like that, so we'll choose the option B and get the answer done. But if you had two options like this, strictly decreasing or decreasing, which you will choose? You will choose strictly decreasing because interval is what? Open. If you had closed only, no? If you had closed, look at this. If I talk about this interval, if I talk about this side, or if I talk about this side, here it is increasing, sir, then it decreases. But this beta is kept open. They have kept the point 0 at point 0, no? This is coming from increasing side and going on the decreasing side. Getting it? So at point 0, we have kept it open. Pi also is kept it open. So for that reason, we can go with the option number B. B will be more accurate if I had option D as decreasing. Clear or not? Is this clear now? Does this make sense? Yeah? Okay. The function given over here is decreasing on which interval? Simple problem. We'll find derivative. We'll have 4x cube minus 24x square and plus 44x, correct, and minus 24. Let's take 4 common first of all. We get x cube minus 6x square plus 11x and minus 6 put equal to 0. If you look carefully, actually sum of odd and even powers of x is having same coefficients. Yes or no? Check here. This is odd and this is for even side. So minus 6 and minus 6 is how much? Minus 12. This is what? This is coming as 12. If you add these two, this and this, if you add, what is the answer? 0. Whenever you have this case, it means x equals to 1 will be a factor, sorry, or a 0. X equals to 1 will be a 0 of this polynomial, and x equals to, or x minus 1. X minus 1 will be a factor of this particular polynomial, or x equals to 0 will be, so x equals to 1 will be a 0 over here. Check. 1 cube is 1. This is going to be minus 6 plus 11 minus 6. So 1 plus 11 is 12, minus 12 is 0. Is this clear, everyone? Okay. Sum of the powers of odd terms, basically odd powers coefficient, and even power coefficient, if you add them, is coming as 0. It means 1 will be a factor. 1 will be a factor. Okay. Or if you want, you don't have to do it actually. Not even do that. Because you can say it's going to be what? You will have x minus 1, x minus 2 and x minus 3. How come, sir? Look at the options. 1 3, 1 2, 2 3. But 0 is also there. But 0 is not in a solution over here. Can you see that? If you put 0, you're going to get the answer as minus 24. So 0 cannot be there. 0 cannot be there. Put here 0. You'll have this left. So not equal to 0. Correct? Now draw the number line. What do we have? 1, 2, 3, negative and positive infinity. Coefficient of x you check is positive only, no? If you factorize it will be coming as positive. 1, 1, so positive, positive, positive. Sign will be over here positive, plus, minus, plus, minus. I want to find what answer? Decreasing. So either this interval or 2 to 3. That's only one option, which is option C. Check. In the given option that is given to us, even 0 to 1 is suitable actually. Even 0 to 1 is also suitable. Yeah, 2 to 3 or 0 to 1. Both are correct actually. 2 to 3 or 0 to 1. Both are correct. I made a mistake over here, guys. They're both correct options. I made a mistake while taking this question. Yes. Look at this. They're both coming negative now. Both the places are negative, right? Yeah. Factors are clear. 1 to 2. How's that? This is wrong. Decreasing, right? So we'll have the coefficient as 1, 2, 3. Excuse me. 1, 2, 3. So we have plus, minus, plus, minus. I want to find out decreasing, right? So this is wrong, by the way. Yeah. Okay, this is wrong. Please ignore this. This is wrong. This is incorrect. Yeah. Let me just delete this part. This is incorrect. Your answer will be either option this or this. This is, you cannot have two options, right? That's why even this is actually correct. But look at the intervals. This is most suitable interval, right? 2 to 3. There's no interval 0 to 1. But even 0 to 1 also, no, if I take 0 also, that will be negative only, right? So that is also correct. So logic wise it is correct only. There's no interval as such. Okay. So I'll just change this little bit to make it easy for us. Okay, 1 second. Let me change this. 1 second, guys. I'll change this. Okay. I'll add this as, let's say, 0 to 1. I closed it like this. But that is also right. That is also right. Okay. 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 Now it's wrong, right? All right. Moving on. Clear? Next question. Next question. Fx is sin x plus cos x for 0 to 2 pi is increasing on which interval? So differentiate first. Okay. We'll get what? Cos x minus sin x equal to 0 to find the critical point. So I get this value as, if you move on this side, you get, this is good question, by the way. This is good question. 1 second. So derivative is coming as cos x minus sin x. This is clear. This is my derivative. Next is to find the critical point. Put it 0. I get here sin x equals to cos x. Bring back. You get tan x equal to 1. Tan x is 1 when? Either in the first quadrant or third quadrant. So tan x is equal to 1 when x is equals to pi by 4 or pi plus pi by 4. Correct? And this value is how much? 5 pi by 4. So this value will have two answers, pi by 4 and 5 pi by 4. I want increasing. Okay. All right. I want this to be in this case only. Makes sense. Option C should be right, no? Not option C. 1 second. 1 second. But look carefully. If I want to check, this is my critical point, by the way. I want to check for this. Derivative should be positive. They're asking us increasing, right? It should be positive. So when I do that, when you have cos x minus sin x as more than 0, more than 0. Now if you take on this side, it becomes basically cos of x is more than sin of x. So I want to understand this only at those critical points. Draw both these curves together on the number line. So cos x is from here. Let's plot the number lines properly. This is 0 and this point is pi and this point is 2 pi. Okay. And pi by 4 is over here. We'll do that first. Let's do the sine function first. So pi by 4 will be, okay, this is not accurate actually. This is not accurate. Yeah. 1 second. Let me just draw the graph properly. Should dip, right? Should dip actually. Should dip like this. Yeah. Now for pi by 4, the graph looks like this. Yeah, the maxima is attained. Then it comes back to 0. It goes back at this point, maxima, and comes back to 0. 1 second. Right? Maxima here and then 0. Correct now? Yes. This is my value pi by 4. Other will be what? After pi, this is the other value which is, please check. This value over here is, guys, 5 pi by 4. 5 pi by 4. Okay. So, I want the case where cos is positive. Cos is more than sine. Where the cos value is more than sine. So, I'll highlight that. Check here. Cos is more over here. Cos is more over here. Then sine is high. So, it will be negative. Here also, again, sine is high only. Again, we have this reason where cos is more. This all reason. Cos is more. So, either interval 0 to pi by 4 or 5 pi by 4 to 2 pi. I want to get cos x more than sin x. So, green part should be above the pink part. So, basically my interval will be what? 0 to pi by 4 union 5 pi by 4 to infinity. Not, sorry. 2 pi. Do I need closed interval? I can take closed intervals. Let's do that. Is this clear, guys? How many of you got this, or how many of you are still confused in this? They're asking in the question that I want this function to be increasing. This function will be increasing when derivative is positive. Derivative is this. When cos x minus sin x is positive, it means cos x is more than sin x. Look at the graph. Critical points over here are clear. One is here and one is right here. So for those two critical points, you can find cos is above 0 to pi by 4, that interval. And after 5 pi by 4 also, cos is above. The green function is cos. This green function is cos x. And this function is what? Sin x. Everyone is clear with this, guys? Is everyone clear with this? Have a look. Yeah? Yeah, same thing. Oh, I did not mark it. Option C is correct. Option C is correct. See, the answer is here. For this given function, you give me the answer now. This you all try. I have given you answers for different same question like this. You all try this. Okay. Differentiate and check the interval. This one I will solve for all of you. So this also you try. You'll have the answer 1 by x over here. This will be having a condition for what? Minus 1 upon, no, 1 second. Let me do this. So what we're getting over here, this function given as x upon x plus 1 is there. I want to differentiate it. You'll have the answer as x plus 1 the whole square, guys. And you'll have, what is it? 1 minus 0. Yeah, it's going to be what? Your value 1 upon x plus 1 the whole square is the derivative. So this becomes x minus 1 upon x plus 1 the whole square. That's my derivative. Okay, put it equal to 0, take LCM and find the result from here for the critical point. Okay. Yeah. Help. Question number 7 and 8. You guys solve and let me know which option is true. I can tell you the answer, but I don't want to. I have given you already the answer over here. Yes, but I'll skip right now. You guys first download the notes and then try to solve it. Okay. I've given the answer in the question. I've given you how to solve it also. I've given you the answer as well. Moving on. Function fx is given like this. Differentiate derivative. You'll have the value as, what is this? 1 by 3 x power 1 by 3 minus 1. That becomes 1 by 3 x power minus 2 by 3. That becomes 1 by 3. And you'll have the value as x power 2 by 3 in the denominator, right? So one thing is clear, this cannot be ever 0, right? X cannot be 0. X cannot be 0, right? Yeah. So in the interval minus 1 to 1, in the interval minus 1 to 1, first of all, let's write this. X cannot be 0. X cannot be 0. So if you try to solve this, you'll find you'll have no value for x. You'll have no critical value for x. Can you find this? So it'll be always going to be increasing in nature. Let me know the answer for this question. Try this out. If you put this value 1 by 3 x power 2 by 3 equal to 0. For what value it is 0? For no value. Okay? X can never be equal to 0. There is no critical point. This is going to be a monotonic function and this is having a coefficient positive. We can go with option B. Option B. This one. F dash of x you want to find out 1 minus cos x. Okay. Apply the formula of this part. What is the formula of 1 minus cos x? Yes, half angle formula you apply and again your answer. I've given you, so whatever questions I've given you as homework, I've given you help also in all those questions. If you want, you can help me right now. Anybody wants to solve this question right now? Anyone? What is the answer for this question number 10? What is the answer for this question number 10? X minus sin x. The function is which option? Always increasing, always decreasing, strictly increasing in this interval, let me know. Let me know. What is the answer? Anyone? Okay, then try and solve this and give me the answer in comment section. Okay. Maxima and minima function. Okay. Now, again, before moving on to this, the concept side, let's understand different types of conditions when this occurs. Okay. So I'll take the combination first. This is my combination, let's say. Clearly you can see that for this given function fx, I have the maxima over here and I have the minima over here. Remember, these are called as local maxima and local minima. So I can write here L max, L min. They are called as local maxima, local minima. Okay, what is absolute maxima, absolute minima? We'll talk about it later. Let's stick to right now local maxima and local minima. Clear, guys? This is the point of local maxima, this is the point of local minima. What's the meaning of local maxima, local minima? Before we go into that, let's highlight a point over here as x equals to, let's say, point A, and here point as x equals to point B. So the concept of local maxima, local minima comes from a concept of neighborhood. It's called as NBD of point A. In the neighborhood of the point A, what's the neighborhood? Means right before and right after. This is going to be what? A minus delta. This will be what? A plus delta. So if I have to write neighborhood of the point A, that's my interval. A minus delta and A plus delta represents neighborhood of the point A. Correct? Right? So whenever we are comparing or we want to identify and find out the point of local maxima or local minima, understand this very clearly. In that neighborhood, the function value, so function value at A should be largest, if it is largest for all x, where x belongs to what? Neighborhood of the point A. For all x belongs to neighborhood of the point A, okay, if f of A is larger than its, the value nearby, then that point A will be what? Point of local maxima. Point of local means, in its like basically, what is the meaning of local? In the area, in this basically, when I say local means in my area. So in the area of A, f of A will be largest or strongest, highest. Local minima, same way. We write first neighborhood of the point B. How do we write? B minus a small delta value. So delta means what? Delta is a very small positive value. Delta is a small positive value, a number. So B minus delta comma B plus delta. So when we are writing this value x equals to B, what it actually implies is that f of B is less than all f of x, where x belongs to neighborhood of the point B. X belongs to neighborhood of the point B. That's the meaning of, then x equals to B will become point of local minima. This is the definition part of what is local maxima, local minima. So far, is this clear, guys? I'm asking you all, is this clear? This is a very important concept and many of you make mistakes in it. So let's just understand it. Of course, question solving is easy because we use second derivative test, so it'll become very simple. But the conceptual side is where you make mistakes. And for competitive examination, that's what the clarity is required. That's where the clarity is required. Okay. Yes. All right. So after knowing this, we'll understand same thing. When will this occur? When will this same thing occur? Okay. So we have understood that, yes, sir, this is local maxima and this is local minima because in this neighborhood, this is the highest or lowest value. Clear. When will the local maxima occur and how do we test it? So if you look at the curve before this point, x equals to A, means in the neighborhood of the point A, before and after, look at the slope of the curve. If you draw the slope means tangent, you'll have this kind of lines, right? You'll have slope like this, and again you'll have more steeper slope as you go closer. This is the slope before. These are the slope before. Same way, if you go after the point, Slopes looks like this. You see this? That's my slopes. So basically, if you look at, if I take any one example, if I take any one as the example, before and after, look at this angle made by, of this by the tangent with x-axis here and here. Look at the angle made. Clearly, this angle is what? Obtuse. What is the angle over here? This angle is acute. We know that slope is given by, what is slope? Derivative is given by tan theta, and tan theta in first or second quadrant. Here it is positive, and here it is tan theta is more than 0, and here tan theta is less than 0. So for all acute angle, it will lie in the first quadrant, so positive, and for all the obtuse angle, it will lie in the second quadrant, which will be negative in nature. So acute because positive, obtuse it is negative. Clear, guys? Positive and negative. So you can see that slope is here positive, and here slope is what? Negative. Which means what? Which means before this derivative is positive, and over here derivative is negative. So whenever derivative changes from plus to minus, whenever derivative changes from plus to minus, then we call that point as local maxima. So about local maxima, the derivative change will always be from plus to minus. So if I have to summarize this, check here. About local maxima, derivative, differentiation, sign changes from where to where? Plus to minus, always for local maxima. And same you can see for local minima also. This is negative and this is positive. So for local minima, what happens over here? The derivative sign change is from minus 2 plus. Minus 2 plus. Is this clear? This is my local minima, right? At the point B. Look at the slope. If I want to draw it over here, just to show you. Look at the slope here and here. This will be acute. This is obtuse angle. This is again acute angle. So minus and plus. Right? Clear? Okay. Now, same thing. Differentiate. The definitions are given. Global versus local extrema. Extrema means either point of maxima or point of minima. Okay? And whenever you talk about global or absolute maxima, the same thing, by the way, you have to check for interval and endpoints also. Because global maxima basically means that if you have a function given like this, where we have more than one maxima, let's say it's like this, increases, again decreases, goes down, again stop like this. This is my interval, let's say point A and point B. You can see this is, let's say, maxima, max, 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 and this is what? Minima. So basically, when you're talking about global maxima, global minima, you have to check the all critical points value alongside the end points value if the interval is given closed. Okay. If it is open, then don't check for the endpoints, of course, for the interval. Otherwise, check for the endpoints also and find for all the critical points maximum minimum value. Whichever is the largest, for example, this is looking largest to me, that becomes global maxima. And this is smallest, it becomes global minima. So basically, every global minima will also be a global, it will also be a local minima, and every global maxima will also be a local maxima. Every global maxima will also be a local maxima. But every local maxima may or may not be a global maxima. For example, this is a local max but not global max. Clear, everyone? Is this clear? Okay. Yeah. Yes. I have already summarized all these points with the help of figures. Now there's two ways to solve questions on maxima and minima. The first method is called as first derivative test. It's called as first derivative test. What we did right now, we look at the sign change of derivative. If f dash means derivative change from plus to minus, it's called as local maxima. Minus to plus, it's called as local minima. We just saw this. For local maxima, plus to minus, we just saw this, right? I wrote the summary over here. Check. Local maxima, plus to minus, local minima, minus to plus. Local maxima, plus to minus, local minima, minus to plus. This is what point of inflection. What is this? Look at this. So, this is my local maxima, this is my local minima. Clear, sir? But if you look carefully, there's a point that is hidden over here. This point about which the concavity is changing. This is concave down, this is concave up. Means about this point, this is going to be plus, minus, here also minus. Means sign is not changing. Derivative is negative only. So when the sign does not change, okay, sign does not change, then and the concavity is changing like this: concave down, concave up. Can you see this? Cupping down, cupping up. That point here is called as point of inflection. This is called as point of inflection. Okay. Now this is what we use in maximum number of questions. Even in boards, if they don't mention you to use first derivative test, you can go with this method, which is relatively, which is simpler and of course time saving. What is the method? You have to find the first derivative, put equal to 0. Step number 1. Step 2 is to find the critical point, or sometimes we call as stationary point or point of extrema. Number 3, find second derivative, find this value, what is this, and check. Fourth point is this, f double dash of, let's say I got critical point as a and b. F double dash of a is negative or f double dash of b is positive, depending upon the question to question. If it is negative, then x equals to a is local max. If it is positive, means x equals to b is local min. So x equals to a will be local maxima when double derivative is less than 0. When double derivative is more than 0, it will be local minima. It will be a local minima. Yes, guys. Clear? Okay. Yes. As I mentioned, for absolute maximum minimum value and it's given as closed interval, please check f value at all the critical points and also at the end points of the interval. The largest value will become absolute maxima, the smallest value will become absolute minima. Okay. So let's solve some questions on this, and then I'll give you some homeworks also in this. Okay. fx at x cube minus 3x is there. We need to find the local maxima, local minima. Starting with what first step? F dash of x is 3x square minus 3 equals 0. Take 3 common, you get x square minus 1 as 0. Right? Correct? Bring this over here, you get x square minus 1 is 0. Means x value is either 1 or minus 1. X value is either 1 or minus 1. We have 2 points. So either I can use local minima, I can use first or second derivative test. So I'll do both for this question. Okay? I'll help you with both the methods. First derivative test. First derivative test. Let's do this. Let's plot the points. We have minus 1 and 1. This is negative infinity. This, look, the coefficient will be x minus 1 and x plus 1. So this is positive only everywhere. So plus, minus, and plus. This is plus, this is also plus. Okay. Now I want to check. Look at the sign change. Sign change you look at. Okay. Plus to minus. This is the sign change. Sign changes plus to minus. Right here. Sign changes what? Sign changes what? Minus to plus. It is minus to plus. So what is the clarity that we have over here? Check. This is my x equals to minus 1 is maxima, and this x equals to plus 1 is minima. Sign from plus to minus is maxima and minus to plus is minima. This is my first derivative test. Let's do the second derivative test also. But before I do this, I'll ask you all, anyone has doubt in the first derivative test method? Anyone in the class has doubt in the first derivative test method? I'll repeat again. So you differentiate this function, you get the critical point, stationary point, whatever you are calling, plot on the number line. Now check, bacha, coefficient of x, here it is also positive, here also it is positive. So plus, minus, and plus. Clear? Okay, sir. Once we have that, look for, once this is basically same as inequalities, right? Once we have plotted the sign change because of the powers of factors is 1 and 1. Now let's look for the sign change. Sign change is here, plus to minus. This is point of local maxima. Here it is minus to plus. This is the point of local minima mentioned over here and here. Okay, look at this second derivative test. Second derivative test. One second, let me just write it better. It doesn't look good and looks not clear actually. So x equals to minus 1 is local maxima point, and x equals to plus 1 is local minima, point of local minima. Okay, L min, L max. Second derivative test. Okay, now for this, if you're checking again, what do you have to do? Differentiate one more time the function. We get this value as 6x. Check f double dash of x at the point 1, we are getting this as 6, and derivative at the point minus 1, we are getting this as minus 6. This is positive, this here is negative, positive and negative. It means what? X equals to 1 is local min, and this is nothing but x equals to minus 1 is local max, right? Second derivative is negative means local maxima, and second derivative is positive means local minima. So both the methods are clear, I hope. Any doubts you have, please ask me. Some questions to solve. Okay. Yes. The local maximum value of fx, we're looking to find out that. How define, sir? Let's do this. So we have to find differentiation first. We'll get what? 4x cube minus, we're getting 16x, that's it. 4x cube minus 16x, correct? 4x cube minus 16x. We have something common, right, guys? We have 4x common, x square minus 4. So we have the points as 4x, x minus 2, and x plus 2. Critical points are 0, minus 2, and 2. What we're going to do? Find second derivative now. Differentiate this part again. We'll have 12x square minus 16. Okay. Check at 0. You'll have this as minus 16. F double dash of 0 is what? Minus 16, which is negative. So x equals to 0 is a local maximum point. What about other two values? If I take minus 2 or plus 2, it'll become what? 4. 24 minus 16 is what? 8. So both these points are point of local minima. Local minima. So I want to find the local maximum value. So I want to find the value at the point 0. It will be 0. Your answer will be what? 3. Your answer will be 3. X is 0, 0, 0 plus 3. Answer is option C. All clear? Yeah. The minimum value of fx equals to x plus 1 by x. We want to find out minima. Start again. F dash of x will be 1 minus 1 upon x square. First step to do what? Critical point. Of course, x is positive, so we don't have to worry about this being 0. I get x square equals to 1, so x value is either plus 1 or minus 1. X is either plus 1 or minus 1. Try. If I take here minus 1, it becomes minus 1 and 1 by minus 1. Right? I want to find out double derivative, right? If I want to find out double derivative, I'll get this value as 2 upon x cube. I want to find minimum value, right? That will happen when it is positive. So f double dash at 1 will become what? Please check. This shall become value as 2 upon 1, which is going to be, what is it? Of course, positive. So this is the point of minima. This is the point of minima. Point of minima. So find the value of the function at 1. You get f of 1 as 1 plus 1 by 1. That is how much? 2. That is how much? Option B, 2. Okay. Maximum value of sin x plus cos x. I have taught you this already, but let me remind you again. Whenever you are having, I have explained this again in your one-shot session also, whenever you have a sin x plus b cos x, a sin x plus b cos x, always y max will be what? Root of a square plus b square. Please remember this, okay? And y minimum will be how much? Minus root of a square plus b square, because in lot of MCQs, this formula will be very much helpful. So let's check over here. Your value for a in this question is 1 and b is also equal to 1. A and b are both 1. So answer becomes what? For by maximum, you are looking for maximum value. It becomes root of 1 plus 1, that is root of 2. Answer is clearly option B. Yeah. Next. Maximum profit we're looking to find out. So we have the profit function. Same approach, derivative we're going to find out. This will be 0. We have 24 minus 36x as 0. You get the x value as what? 24 by 36. That becomes 2 by 3. Now, one more thing you remember, whenever you have only one critical point, do not go and check if it is point of maxima or minima. Do not do that. Until unless there's an option given as none of these. I'll repeat myself. If you have only one critical point, they're asking us maxima. Means of course it'll be same point, right? Point of maxima. But if you have an option given as none of these, then of course it can be point of minima also, right? So if you don't have an option like none of these, then simply put the value back in the function. So let's find P of 2 by 3. It will become 41 plus 24 into 2 by 3 minus 18 into 4 by 9. 3 8s are 9 2s are. I get 41 plus 16 minus 8. So 41 plus 8, the answer is 49. Option is B. Option is B. Yeah. Clear? Alright guys. Yes. Alright. So I have given you few more questions. Fifth one. This is again question number 6 also. Fifth one I'll help you solve. But these are very easy ones. Can you see? Question number 6. I've given the answers also. So I've given you answers also for all the questions that I'm giving you as homework. So please try to solve them. Okay? Because just watching any lecture will not be helpful to us. Will it be? No, right? So how do you learn properly from any particular YouTube lecture? If there's enough number of questions done in that class, and once the teacher has done it, please try to solve it without any solution, without any help, whether from teachers, friends, or any AI tool. Okay? Please make sure that you have done with solving of all the questions. Download this notes from the AIO page and start learning right away. Okay? Sum of two positive numbers is 24. Okay, sir. It means one number is x, other number is 24 minus x. The minimum value of the sum of their squares. Let's say square will be x square plus 24 minus x the whole square. They're asking us to minimize this value. Differentiate ds by dx equals to 2x plus 2 times of 24 minus x into minus 1, because differentiation of minus x is what? Minus 1. Put equal to 0, you get 2x. And yeah, excuse me, we don't have to write 2x, right? Because 2 is common actually. Take 2 common, you get x minus 24 minus x. So if you move on this side, you have 0, you have x minus 24 and plus x. Open the bracket, you get 2x as 24 and x will be what? 12. We have only one critical point and I want to identify the two parts. If one part is 12, sir, other part is 24 minus 12. How much is that? Of course, 12. So my answer is what? The answer is what? The parts is 24 and 24. But I want to find out minimum value of the sum of the square. I want to find out the minimum value of sum of the square. Okay. So check once over here. You'll have s value as, put this back over here. You'll have 12 square plus 12 square. So 144 plus 144. That becomes 288. That becomes 288. And that is option number B. I have given you answers, questions also for some of the homework. Please solve it. Okay. And if you have any doubt, don't forget to put that in the comment section. Okay. So I've given you close to 6-7 questions as homework. I've solved also for all of you more than 20 problems from all the 3 different topics. Let me know how was this session and did this make sense? Was this able to help you or not? Okay. Any doubt you guys have, you can ask. Otherwise, I'm going to end the class now. The session is over. I have done all the 3 different concepts of application of derivative. In the next class, in the next live, we'll try to complete our PYQs of this chapter. KCET PYQs. All right. If nothing is there, then I'll end the session and see you all in the next class. Okay. And do not forget to check out our AIO page, all-in-one learning page. So we have given you access to all of that already. Okay. Let me show you one more time. Just one second. Okay, I won't need to save this file now. Very important. I have to upload it. I have to give you all these notes. So check this out. This is our all-in-one learning page. How can you find it? So you'll have to check any video. You can check in this videos, this live's description also. Join the free ACE KCET 2027 course now. Click on that link. You'll have this web page. You have to click on buy now to create a login credential. Once you're done with that, you can see that your course will be live over here. YouTube course for grade 11 and grade 12. Click on that. You'll have subjects. You can ask your doubts to Ved. You have assignments. You have tests. All is available. Let's say I want to learn maths. You have all lectures present over here. Assignments are there. Quizzes are there. Class sites are there. All of this is available in our platform. Any doubt or anything you are facing a difficulty in accessing the platform, ask us. We'll help you resolve that so you can learn smoothly. Okay. Yes, guys. Anything else? If it is there, go ahead and ask. Otherwise, I'll see you in the next class. Okay? Great. Then all the best. Keep working hard. Keep smiling. See you in the next class. Take care. Bye-bye.